Okay, so now we are going to do family intersection world. We're just gonna brute force this and see what happens. Cannot do that. Okay, I think we're done. So we just do exact. Great. Again, we're just gonna brute force. I think we could do a bit more intro. Probably. Okay, we're just gonna continue brute forcing until it stops working. Can we do this? We can. Okay, this looks pretty obvious. Um, right. I mean, X plus in A, X plus in B. T is one of these, so X has to. So we want to destructure on that. Now handling the B case. Yeah, I think this is where we need a definition. Alright, maybe we don't do this. Unless... No, let's not do anything weird. Okay, other direction. Um, don't think we can rewrite this period. Can we? Yeah, that's not. Okay. I mean, this is pretty obvious, so let's just go apply dot intro and dot intro to start taking the case. So we want to prove x belongs to A. Oh, we don't need to do this. We can do have h3, which is going to be hxab applied to A. Okay. Have h4, which is equal to hxab applied to B. And alright, so the left is going to be this one here is going to be apply h3, and then we have to do a rewrite pair, and then left ourselves, and then the right is going to be apply h4, again, and then pair, and then right, and then ourselves. And great, okay, this continues to work. So more brute forcing. Maybe we just rewrite this. Does this help? I think we're supposed to do something with this. Actually, let me just see what I'm supposed to prove. Intersection of F union G equals intersection of F. Oh, this is family intersection. Family intersection of F intersection of intersection of G. So here's F, here's G, the stuff in the middle, intersection over all of this stuff here. Okay, yeah, this makes sense. Maybe counter positive here. Do we get a contradiction here somehow? Let me see. So intuitively, why is this true? We have all the sets of F here. We have all the sets of G here. So we have A equals F minus G B equals F cap G, C equals G minus F, right? So the first one here is intersect over everything A, B, C. This is the left-hand side. And the right-hand side is going to be intersect over A comma B, and then intersect with family intersect over B comma C. Right, so basically, if it's in the left, right, it means it's in A, it's in B, and it's in C. And again, if it's, right, so both sides are equal to saying, if and only if it's in part A, part B, and part C. And how do we express that? So here's the same. So T is in F union G, it means T is in A, B, and C. Alright, I think I know what to do here. We're going to just apply n.intro. And let's just brute force this. So intro x2, h x2f. That's great. I think I want to apply hxfg. And then I'm going to do apply or dot in L of hx2f. Okay. This should be the same, I think. So intro x2 hx2g, and then we're going to apply hxfg, and then we're going to apply or dot in right hx2g. Okay, other direction. So again, we're now going from this to this, and so here, if it's in this, it has to be in A, in B, and in C. So in all of A, B, and C. And yeah, it should just work the same way. Well, what is called intro? This x2 should probably be better called, let's call it t. It's actually a set, you should call it s. But t will do for now. I think I would want to break that apart. Okay, and then I think I want to use this. So yeah, I think I'll do this up here. Right, Control X. we continue brute forcing. Actually, let's read the problem statement. What is the problem statement? So, we want to show that if A is in the intersection of the family intersection of F, then for all S in F, A is a subset of S, if and only if. So, if it belongs in this, it definitely belongs in everyone except, and if it belongs in, oh yeah, this is intuitive. Apply intro X. SHSF. Now we can go for single element. Okay. How do we prove that X belongs in S? This should not be this. Should come HAF. Okay, and then we'll call this X then. X belongs in A belongs in this. Yeah, I think we need to exploit this somehow, so. Okay, we can't do that rewrite. Alright, this is going somewhere. And we want to okay. Other direction. Intro HSF. let's call this X HX8. And I should probably call this smaller. Alright, so I think we should just see what happens. And I think we're basically done now. Okay, we will continue brute forcing. Intersection of a family of unions. For every S in F, a set union S is both in G, then the intersection of G is a subset of A, union family intersection of F. Alright, so we pick something here. Which means it belongs in all of them. So it belongs in every single AUS, which means it must either belong in A, which is we satisfies this, or it belongs in every one of these. Okay, this is trivial. intro x, hxg. What is the hint? Writing out the definition. Okay. Darn it, I lost the proof. Okay, so if it belongs in this, right, then it must either, then this is true for all of them, right? Which means either it belongs in A or it belongs in every single thing F. So either it belongs in A or it belongs in every single thing F. Wait. So X must either belong in A or it belongs in every single thing F. This is what we want to try to prove. I feel like I almost want to do called proof by contradiction. Because it gives us more, hang on, so. Okay, rewrite mem union at hxaf, and then push neg at hx, and then arc, maybe push neg. Okay, fine. Arc cases hxaf. Right, so one of these is going to give us false. I need to decide which one to use. But I actually don't know. Wait, we have x does not belong in A, right? Which means that x must belong in S for all of this. I think it actually doesn't matter which one we apply, because we'll end up using both. I want you to somehow invoke this thing, right? So, if x does not belong in A, it means that the only way this is satisfied is that for all S in this, x has to belong in S. Right, so I have all the pieces here. I just can't. Here's what I'll do. I want to MS there we go. Okay. This is going to do it. This is going to do it. Now that we have this F, we can have H3 be H1 F H1. Okay, so AUF belongs in G, and now we can apply this to HXG of this. Okay, now we're basically done. So this, and this have contradictions. So our cases H3 with H3A, H3F. This one here is going to be apply HXA to H3A. And this one here is apply HF2 to H3F. And we made a mistake here. HXA. Great! Okay, so we just brute forced this entire section.